So let's begin, and our goal today really is to explore how genomics can be integrated into midwifery to enhance understanding and improve discussions, ensure that every family receives respectful and dignified support throughout pregnancy and beyond. So with that, let's see if we can now make genomics your ally in your practice. Now, last time we were at this event, it was in Birmingham, and we did a little snapshot survey, and we asked people if they knew about the words genetics, genomics, and epigenetics. And I think most midwives were comfortable with the word genetics, but not so sure about epigenetics and genomics. So what we wanted to do was start by explaining these important terms. So, as you're aware, as humans, we're made up from lots of different cells. And inside nearly every cell, we will find chromosomes. So chromosomes are those thread-like structures that hold our DNA. And our DNA, within our DNA are genes. So genes are specific sections of DNA, start that again, specific sections of DNA that code for a protein. And these, of course, decide things like physical traits, like how tall we're going to be, our eye colour, and so forth, but also can influence health traits as well. Now, genetics focuses on genes, focuses on these sections of DNA that code for proteins, and how variation within our genes can cause differences which include health conditions. But genes only account for 2% of our DNA. Now, during a lot of my training, we were told that the other 98% of DNA was junk DNA, doesn't really do anything. How wrong we were, it's actually quite important. So when we're talking about genomics, we're talking about all our DNA, not just our genes. And that's very important. So I like to think of genetics as being a subset of genomics. That's quite an easy way, I think, to think about it. So let's then think about what is epigenetics. So epigenetics is the study of how genes can be turned on or off without altering our underlying DNA sequence. And this is an important mechanism that plays a crucial role in cell differentiation. And that ensures that cells can develop into specialist cells such as nerve cells, liver cells, and blood cells. And in terms of the developing embryo, epigenetics, of course, is crucial. But other factors also influence epigenetics. So external factors such as diet and stress, lifestyle, smoking, exercise, all these can cause genes to be switched on or off. And that can potentially affect our health. Now, some of these changes can be beneficial, but some can be harmful and can contribute to illness such as cancer. So I always think of epigenetics as being a little bit like a light switch, like a dimmer switch. So some factors can turn a gene totally off or totally on, or it can just dampen it down a little bit or enhance it a little bit. So hopefully that's given you a little overview of the difference between genetics, genomics, and epigenetics. So now we're just going to give you a background as to why genomics is becoming increasingly important in healthcare. So in 2003, scientists announced for the first time that they'd managed to sequence the entire human genome. It had taken thousands of scientists 10 years, and it cost over $3 billion to do that. Now, since then, both the cost and the time frame it takes to sequence an entire genome has been significantly reduced. And that means that we can now use whole genome sequencing at scale for research, and then, where relevant, translate those findings into benefits for patients. The first major project in the UK which helped our understanding of genomics and health was the 100,000 Genome Project. That was launched in 2012, and 100,000 NHS patients with either rare disease or cancer underwent whole genome sequencing. And the results were fascinating. Up to half of cancer patients received a clinically actionable result. So we changed the management of their care in some way because of the whole genome sequencing result. 1 in 4 participants with rare disease received a diagnosis for the first time, and that can be life-changing for these families. And on this slide, we've just got a story of one such family that was helped by this project. And they had a baby boy born who became very unwell shortly after birth and sadly died 4 months later without a diagnosis. They took part in the 100,000 Genome Project, and eventually whole genome sequencing revealed a small genetic variant that meant that this child had died from a rare metabolic condition, which meant that he couldn't take up vitamin B12 into his cells. Now, unfortunately, that was too late to help him, but when they had another baby some years later, we could test him. He had the same condition, and we could easily treat that condition with vitamin B12 injections, and he had a normal life without any progression of that illness. And so it was findings like this in this study that helped pave the way for what we now call the NHS Genomic Medicine Service. So the GMS, for short, was launched in 2018, and the overall aim really is to harness the power of genomic technology and bring those benefits to the patients in our care. To do this, we've had a series of documents outlining the strategic direction for genomic medicine in England, and the most recent of which is the 2022 Accelerating Genomic Medicine in the NHS document. And this details a 5-year plan. It talks about embedding genomics at all aspects of healthcare. It talks about equitable testing, about developing our digital and data capability in genomics, and promoting research and innovation and bringing those benefits at speed to patients. And all this work is going on in the background now, and it's a very exciting time. Another important document that is central to the GMS is the National Genomic Test Directory, and this details all the genomic tests that are commissioned for the NHS in England, and it's over 600 pages long, so you can go and access it online. But just to give you an example, in 2024 we did over 800,000 genomic tests in England on the NHS, and it's increasing every year, and of course many of these are in maternity. Now, the GMS is not just one organisation, it's multi-organisational and multi-professional. It's led out of the genomics unit at NHS England, and we have a lead midwife for genomics in this country. We have the clinical genetic services, which are probably better known as genetic counselling. We have the GLH, the Genomic Laboratory Hubs. So we've got a network of laboratories across the country that do perform all our genetic testing. We have the NHS Genomic Medicine Service Alliances, and that's who myself and my colleague Jo work for. And this is the genomic geography on this map here. So I work for the purple area, which is central and south, and Jo, who's not here today, she works for east of England, which is the blue area. So genomic geography doesn't match NHS England geography, so it can get a bit confusing. Sometimes our borders cross in funny directions. We also have the Genomics Education Programme, and they are, well, I'll talk more about that later actually, because they provide a lot of free training. I have to mention Genomics England, which isn't part of the NHS, but it is part funded by the Department of Health, and they do the whole genome sequencing for the NHS, but also lead on some research projects. I'm going to mention one of those later. So all of us working in the NHS are involved in genomics, even if we don't always realise it. And just to summarise some of the benefits that genomics has, or the potential benefits of using genomics in healthcare, it has the potential to provide better prediction in terms of identifying who is at risk of certain diseases and conditions. It increases the number of people with rare disease getting a diagnosis. It can deliver more accurate and earlier diagnosis for people with cancer. It can improve our understanding of the underlying cause of conditions, which, as I've kind of illustrated with that little case study, and that in turn can lead to the development of new treatments, new interventions, and deliver what we call personalised medicine, where we're delivering medicine based on the genomics of the person sitting in front of us. This is a very generalised overview of where genomics shows up across healthcare. So what we wanted to do next was to hone in on why it's important for midwifery and for midwives. So this is a document that I think as midwives you should be familiar with. It's of course the standards of proficiency for midwives from the NMC. And this includes the words genomics, genetics and epigenetics. So these are terms that as midwives we must all be familiar with and understand how they relate to our practice. And we're going to give you some examples over the next few slides. So we're just going to work through all of these different areas and just give you some examples, just sort of a snapshot. So starting with identifying genomic risk, and I think midwives have a really important role to play, particularly at the booking appointment, to identify what we sometimes call genomic red flags or genomic risks in pregnancy. And this is where we explore that family history, that medical history. We ask about pregnancy history and any family history of any conditions and so forth. And I think Pregnancy is a time when people often think about inherited conditions in their family for the first time. And of course, midwives have a crucial role to play to ensure that they identify these risks and then refer onwards in a timely manner, so we can ensure that parents can access genomic counselling and further testing where necessary. Now, the little red cards that we've shown on this slide were developed by our colleagues in northeastern Yorkshire, there's just little prompts on there to help you think about what questions you should be asking during the booking interview and how to refer on. And we've got some of these cards at our stand, which is just to the right over there, so do come and see us and we'll give you one of those. So then moving on to screening and diagnostic opportunities. So Genomics is starting to transform prenatal care. We can offer earlier and more accurate screening and more options for diagnosis, and in some cases safer diagnosis. So starting with non-invasive prenatal testing, where of course we take a sample of the maternal blood to analyse some of the placental DNA within it. And of course that gives us more accurate screening and to more people. And we can now offer non-invasive prenatal testing, of course, to women who've previously had a trisomy. And that's a new initiative in the National Genomic Test Directory. We've also got non-invasive prenatal diagnosis, and although it's only available for a limited number of conditions at the moment, then it does afford us the opportunity for some couples to avoid amniocentesis and CVS, which of course carry a risk of miscarriage. So it gives us a safer alternative, and in many cases much earlier in a pregnancy than would currently be offered with CVS. And if you want to know more about non-invasive technology, then we did a webinar for Matflix a couple of weeks ago now, and that's available online, so do go and have a listen to that. Also, where ultrasound detects certain anomalies, we can now offer whole exome sequencing, and we're starting to increase the rate of prenatal diagnosis in these cases by up to 10% by using exome sequencing in pregnancy. But while these advances bring significant benefits, then there are also ethical considerations to think of as well. We don't always get a result for all people. We can promise a lot, but we don't always, not everyone's going to get a result. We have to think about informed consent and the psychological impact of some of the findings. And of course, there's also the chance of potential misinterpretation when we're interpreting the genome. But midwives can play a key role in this in terms of supporting families and signposting them to additional support. So moving on to re-evaluating diagnosis. So genomics can play a key role in re-evaluating some diagnoses, and a really good example here is in the world of gestational diabetes. So monogenic diabetes is a rare inherited form of diabetes that's caused by a single genetic variant. Now, the most common type of monogenic diabetes is something called glucokinase hyperglycemia. I'll call it GCK for short. And these people, if you've got GCK, then you naturally run at a slightly higher blood sugar level. We think about 1 to 2% of people who are currently diagnosed with gestational diabetes are actually misdiagnosed and may in fact have GCK. And this is important because people with GCK don't usually require medication, and therefore with a misdiagnosis it could lead to unnecessary intervention, such as receiving insulin when they don't actually need it. So testing for glucokinase hyperglycemia is available in certain circumstances, and our colleagues in the South East and East GMSAs have developed a really nice pathway and some little cards to help you with this. They've also developed a really good training module, so if you're interested in monogenic diabetes, do go and have a look at that. And the QR codes are on the slides, but again we've got leaflets at the desk over there as well. So moving on to providing answers for families and family planning. So stillbirth, of course, is a difficult reality for maternity services, and it's always harder, I think, when we don't get a reason for why it might have happened. The last Embrace UK report showed that around a third of cases of stillbirth, we didn't get an explanation But what we're now starting to find is if we use genomics appropriately, we can increase the diagnosis rate of these unexplained cases by up to 10%. And of course, again, that's not everyone, but for those couples where we do get a diagnosis, that can make a huge difference and can also inform future pregnancy planning. If you want to know more about genomics and stillbirth, then we've got a whole Matflix session on the 18th of June, and my colleagues Denise and Tina, who are also GMSA lead midwives, are going to present that along with Emma Tomlinson from the Tommy's charity. So come along and you'll hear more about that then. And then finally, I just wanted to mention research. So there were a couple of studies that we wanted to mention. The first is PALO. So PALO stands for pharmacogenetics to avoid loss in hearing. So pharmacogenetics or pharmacogenomics is the study of how genes affect how a person responds to drugs, and how well that drug might work, or whether they get side effects or not, and what those side effects might be. Now, we've identified 3 genetic variants so far that seem to be linked to hearing loss in people who receive aminoglycoside antibiotics, the most common of which is gentamicin. So the PALO study trialled point-of-care testing by staff in the neonatal unit. Results took around 30 minutes. They could do it bedside or cotside. And then if we found the baby had one of those variants, then we wouldn't give aminoglycoside antibiotics if clinically that was appropriate. So again, really successful study, and at the moment, supported by NICE, they're undergoing further technological assessment of that technology to see if it should be rolled out on a much wider basis. And then the second study that I wanted to mention is the Generation study, and that's currently ongoing at selected sites across England. And the aim with that is to use whole genome sequencing as a screening test. So this is using genome sequencing in a completely different way. At the moment, we use it for diagnosis, but this is using it for screening in asymptomatic, healthy individuals. So we want to screen 100,000 newborn babies for over 200 rare but treatable genetic conditions. So far, we've signed up around 10,000 families, and the study is going to continue to the end of 2026. And there's going to be a few more sites onboarding in the next few months. And again, if you want to know more about that study, come and speak to me afterwards. So finally, what we wanted to do was just point you in the direction of some further resources to support you in your work. And we want to encourage all midwives and all maternity staff to be genomic curious. And there are lots of resources out there to help you upskill and keep up to date. Firstly, genomic education programs, so I can mention that on one of the other slides. Lots of information on that website. Starts really basic, like what is a gene, what is DNA, what is a chromosome, and then increases in complexity. There's a special page for midwives as well, so do go and take a look at that. Also gives you information on right up to master's level study in genomics. And secondly, wanted to mention GeNotes. So GeNotes literally stands for genomic notes, and it's a whole library of information and clinical advice. It's good quality, concise information that you can use in your clinical practice. Just type something in. So if you're not sure what whole genome sequencing is, type it in, it'll tell you what it is. Gives you information on different conditions and so forth. And there's also a whole section in there on fetal and maternal health. So do go and have a look at that. Now, there are lots of resources out there to help midwives upskill, but it can be difficult to know where to start. So we've developed something called the Genomic Learning Passport for Midwives. And the idea behind this is it will guide you through those key resources, again, starting really basic at what is DNA, and then increasing in complexity. It's a Word document. You can download it from the website, and then you can edit it according to your learning needs. And you can record your own personal genomics learning journey in a format that you can use for your revalidation. So hopefully it'll save time. So again, do go and have a look at that. Again, I've got cards on it over on our table if you want to take one away with you. And also it's important that midwives know who to access and where to go for further advice. And it can vary in different units. So I know that in some units they encourage midwives to go direct to clinical genetics or genetic counselling services, but in other areas they would prefer you to go to your local fetal medicine department, or perhaps you've got a specialist midwife that's working in genomics at your trust. So find out about your localised pathways. If you want to know who your local genetics, clinical genetics department is, then there's a great little interactive map on Knowledge Hub that you can go and type it in and you can find out who to refer to. Stay up to date by signing up to various newsletters. So again, you can come to our desk and sign up to our newsletters. The Genomics unit also have a newsletter, as does the Genomics education programme. We also have National MIGS Net. So MIGS stands for Midwives in Genetics and Genomics Network. It's comprised of the lead midwives for genomics across England, as well as lots of different professionals who've got an interest in genomics. And we meet monthly. If you're interested in coming along, then email us, and if we've got space, you can join in. You can join permanently as well if you want. So we work collaboratively on a lot of the projects that you've heard about today. And finally, I can't not mention all the various local and national support groups which do an incredible job in supporting parents and families. And a good place to start is Genetic Alliance, because they've got a directory of lots and lots of different support groups in relation to genomics. So this is my final slide. So this is really just say we hope you've got an understanding of where genomics fits into maternity care and why it's important for all of us to be aware of. And this is our call to action, because we think we've all got a role to play improving equity and accessibility in genomic care. So what can you do? Well, genomics is here to stay. It's not going anywhere, and it's only going to increase. We all need to upskill. I need to upskill. We need to update all the time. So this is a call for everyone to do that. We need to be able to recognise those genomic risks, especially at that booking appointment, and refer early. So midwives have a crucial role to play there. You need to familiarise yourself with your local pathways, who to refer to, who to get advice from when you're caring for people. And we ask that you go back to your units today and share a little bit of what you've learned about genomics, and take some of our information away with you and share it in your maternity unit. Because genomics isn't niche anymore. It's not just for screening midwives or fetal medicine midwives. Everyone needs to know about genomics. And by having a genomic knowledge, then I think it can empower us as midwives to empower the people in our care, and help people make informed and personalised choices that are right for them. So I'll finish there, and obviously if you've got any questions afterwards, and you can obviously come and talk to me as well over at the stand later today. Thank you.